Hello, so in this video, we're going to look at proving something called the quotient rule. So this is very similar to the product rule that we did in the previous video to this one. But this time, this is to do with differentiating quotients. So differentiating one function divided by another function. And so the rule, if we just write it out. So the derivative with respect to x of a function of x divided by a function of x. But I'm going to make a point here that g of x does not equal 0, because if g of x were 0, then this fraction, this quotient, would not be defined. So when we want to differentiate one function divided by another function, the quotient rule tells us that the result will be the derivative of the numerator function with respect to x multiplied by g of x from the bottom. And then we're going to subtract the derivative of g of x with respect to x multiplied by the f of x on the top. And then we divide this all by the square of g of x, so the square of our numerator function. So this is the the quotient rule. And what we're going to do is we're going to try and prove why this result is true. And to do this, we're going to use the previous video. So we're going to actually use the product rule to do this. So let's write proof up there. So yeah, so we want to differentiate x. Differentiate with respect to x of these two functions divided by each other, where g is a non-zero function, because again, we can't have 0 on the denominator. So what I'm going to do is just rewrite this. So we've got d by dx of f of x, and then this g of x to the power of -1, because obviously 1 over g of x is the same as g of x to the power -1. It's important to note that this g of x is not the inverse of g of x, so it's not that. It is literally g of x to the power of -1, so that's something to note. And then what we've got here, so we've got two functions multiplied by each other. So we can just use the product rule because these two functions are a product of each other. So using the product rule, so we know that we're using the product rule, we differentiate one function, times it by the other, and then add that to the derivative of the second function multiplied by the first function. So what we're going to do is differentiate the f with respect to x and multiply that by g to the -1, and then add that to the derivative of g to the -1 with respect to x and multiply that by the f function. Okay, so that's fine so far. With this first term, I'm just going to copy that again on the second line. So df by dx multiplied by g to the -1. I'm just going to make a note here that we're using the product rule. So using product rule, that's how we've got this result so far. And then we want to differentiate with respect to x, g to the power of -1. Okay, so this, we're going to have to use the chain rule with this. So let me go to a new page. So we want to differentiate with respect to x, g of x, all to the power of -1. So again, what we've actually got is a function of a function. So the first function being the 1 over x, and the second function being this g of x within the 1 over x function, or the x to the -1 function. So we're going to use the product rule, the chain rule to differentiate this. So if we let 1 over g of x equal, I'm going to call it capital F of x. And if we let g of x just be, we'll call it capital G of x this time, then we know from the quotient, the chain rule, we know that when we differentiate f times g, so these two functions multiplied, we know that we're going to get, sorry, my bad, not these two functions multiplied, f of g of x, so the function of the function, when we differentiate this with respect to x, what we're going to get is the derivative of g with respect to x multiplied by the derivative of f with respect to g. Okay, so if we differentiate the capital F, so this 1 over g of x with respect to g, well, that's going to give us, just let me make this all a bit smaller so I've got room. Okay, yeah, so if we differentiate the f with respect to g, so that's differentiating, so let's just be clear about this. We're differentiating this 1 over g of x, so g to the power of minus 1 with respect to g, so with respect to g of x. So that's just exactly the same, essentially, as differentiating 1 over x with respect to x. And if we differentiate 1 over x with respect to x, we would get negative 1 over x squared. But in this case, because we're dealing with g of x's, it's going to be 1 over g of x all squared. So that's our df by dg bit done. And then now we want to do the dg by dx part. So again, if I just make this all a bit smaller, try and move it up like that. Okay, great. Yep. So now what we can do, just rub that out there. So yeah, so now we want to do our dg by dx. So differentiating this g of x with respect to x, well, that's just literally dg by dx. Don't really need to do anything with that part there. So great, yep. So we've got this result, and we've got this result here. And now using the chain rule, we just multiply these two results together. And so the derivative with respect to x of g of x to the power of minus 1 is exactly the same as minus 1 over g of x all squared multiplied by dg by dx. And the chain rule gets us that result there. So now we can go back to the previous slide. So now we know this result because we've just worked that out. And we worked out that that was 1 over g squared. So I'm just calling this g of x g just for just to make it all more simple. And then we're multiplying this by dg by dx. So multiplied by dg by dx, and we're multiplying this by the function f. Okay, cool. So now if I just copy out that this last line on the next slide, so we've got df by dx times g to the minus 1. Well, this is just 1 over g. And then what we're doing is that we're subtracting 1 over g squared multiplied by dg by dx. Okay, cool. So now we want to try and simplify this. So what I'm actually going to do is just rewrite this a little bit differently. So I'm going to put this d of f by dx on top of this fraction with the g on the bottom like that. And I'm going to do a similar thing here. So put dg by dx on top, and then put this g squared on the bottom. Okay, so we're subtracting two fractions, so we want a common denominator. And so to do that, what we're going to have to do, sorry, I forgot the f here, my bad. There should be an f up here. So f there, and an f there, because we've got this function of f that I completely forgot from the product rule. So we've got f there, f there. So yeah, we want to get a common denominator to subtract these two fractions. So we can do that just by putting another g on the bottom there, but that means we're going to have to put a g on the top there. So now we've got our common denominator. And so what we've got on the top is df by dx times the function g, subtract dg by dx times f all over g squared. And this is the result done. So that fraction there is exactly the same as what we've got over here, actually. So df by dx times g. So that's that bit there, df by dx times g. And then subtract dg by dx times f. So that's that bit there. And that corresponds with that there. And then on the bottom, we've got the g squared, g of x squared. and that's what we've got down there. And so we've proved the result for why the quotient rule is the quotient rule. So this is the quotient rule, and this is how we prove the quotient rule.